We have an initial value problem here. dy dx is equal to the fraction 3x plus 2y over 3x plus 2y plus 2. Initial condition, y of -1 equals -1. We'll use the substitution u is equal to 3x plus 2y plus 2. And since we're eventually going to replace the derivative dy dx, we need the derivative. So du dx is equal to 3 plus 2 dy dx. What happened to the x? Well, dx is 1, right? We're going to solve for dy dx so we can then substitute it by subtracting 3 from both sides, then dividing both sides by 2. We have 1/2 du dx minus 3/2. Substituting yields 1/2 du dx minus 3/2 on the left-hand side. That replaces the dy dx. And on the right-hand side, the denominator gets replaced simply with u. But the numerator is 3x plus 2y, but with no 2. You can convince yourself, I'm sure, that this is u minus 2 in the numerator. And that actually brings up the fact that we had a choice in this case of what our substitution is going to be. We could have, if we wanted to, said that u is equal to 3x plus 2y. Then the denominator would be u plus 2. It's a choice. I'm going to go with what I've already done here. Now, on the left-hand side, nothing really interesting is going to happen, but we can clear the fraction. On the right-hand side, since we have u minus 2 over u, we can actually separate the numerator of that fraction. And the right-hand side becomes 1 minus 2 over u. Adding 3/2 to both sides and then multiplying by 2 to isolate du dx gives us du dx is equal to 5 minus 4 over u. This is kind of problematic because it doesn't fit any of our categories. But if we get common denominators on the right-hand side, we get 5u minus 4 over u. Now we have du dx is equal to the quantity 5u minus 4 over u, and that is now separable. So we've got u over 5u minus 4 du is equal to dx. And as we've seen, we're going to solve this by integrating both sides. On the left-hand side, our u over 5u minus 4 is an improper fraction. We're going to handle that using long division. U divided by 5u minus 4 is going to give us 1/5. We divide the first term into the first term, multiply and subtract, so we have negative u and then plus 4/5. So we have plus 4/5 over 5u minus 4. That replaces the integrand on the left. So we have the integral of 1/5 plus 4/5 over 5u minus 4 all times du is equal to the integral of dx. In the integrand with respect to u, that 5u minus 4, well, we're going to use a substitution rule. I'm going to let t equal 5u minus 4, which gives us a dt. I'm so used to writing a du. dt is 5 du, and so we see we need to multiply and divide 4/5 by 5. The result after integrating is going to be 1/5 u plus 4 over 25 natural log of the absolute value of 5u minus 4. And on the right-hand side, we integrate dx to get x, and don't forget our constant of integration. I'll clear the fraction, the 1/5 u, by multiplying everything by 5. That gives us u plus 4/5 natural log of the absolute value of 5u minus 4 equals 5x plus, now this would be 5c, but I'm not going to do that. I'm just going to relabel the constant. We'll say plus c and then make the previous constant c1. And then remember, our substitution was u equals 3x plus 2y plus 2. So we have 3x plus 2y plus 2 plus 4/5 times the natural log of the absolute value of 15x plus 10y plus 10 minus 4 inside there is going to be a plus 6. The right-hand side remains unchanged, 5x plus c. I see that we have x's on both sides. Combining like terms is going to give us, let's see, I'll write it as 2y minus 2x plus 4/5 natural log of the absolute value of 15x plus 10y plus 6 is equal to a constant. And you may notice I didn't write down the 2. That's because I rolled the 2 into the constant, which also means I changed the meaning of the constant. So I'll go back, call the previous constants C2, and I was about to box this, but I remembered this was an initial value problem. We know that y of -1 is equal to -1, and that's going to give us that c is equal to 4/5 times the natural log of 19. Finally, our solution is 2y minus 2x plus 4/5 times the natural log of the absolute value of 5x plus 10y plus 6, are you tired of hearing that one yet, is equal to 4/5 times the natural log of 19.